the next session, for the next session, we have Carlos and Victor co-presenting. Hi, Victor. Hi, Carlos.
Hello.
Hey.
Hello.
Hey.
How are you guys?
Good. And you?
Excellent. You know, that's life in Yash, actually. So how else could I feel? Seeing anything familiar here?
Oh, this will be the first year I'm not in this hotel.
Yep. Did you enjoy the discussions with the community here, or hopefully the answer is yes.
Yes.
Of course.
So guys, how long do you know each other, or is it just now meeting for this presentation, or I'm joking, of course.
No, unfortunately, we've known each other for a long time. Too much time.
Exactly.
Yeah.
We started annoying each other so much that he had to leave the company.
Oh. Okay, but we get her back for this presentation.
Yeah, it's like a marriage, right? You separate for a while and then you get back together.
Okay. Want to say a few words about the topic and about the presentation that we'll be doing?
Carlos?
Yes. So we're going to be talking about, this is pre-recorded, about Kubernetes and progressive delivery and doing like Canary deployments, feature flags, and we'll have a demo. We had to mount the video because Victor decided to switch companies in the last week. So we had to edit it a little bit.
Oh, okay.
He's like that. He did it on purpose.
Exactly.
Also the contents, or just the subtitles?
No, only the subtitle for now.
And
the content was changed before that, a week ago, and the title this week.
Okay, great. So should we just run the freshly recorded session and regroup afterwards, comment on that, and maybe take some questions?
Yeah.
Yes, that would be brilliant. The more questions, the better. So
let's do that. Okay, good. Looking forward to the recording then. And I'll see you later.
Yeah.
Okay, thank you.
Hello and welcome to this talk about progressive delivery in Kubernetes. My name is Carlos Sanchez.
And I'm Viktor Farcic.
So I am a cloud engineer at Adobe. I wrote some open source, a lot of it, like the Jenkins Kubernetes plugin, and I've been a long-time open source contributor at Adobe, Apache Maven, Eclipse Foundation, Puppet, and other things. And Victor.
My name is Viktor Farcic. I currently work in CodeFresh. I am a Principal DevOps Architect. I am a member of Google Developer Experts group. I am one of the Docker captains. I wrote quite a few books under the umbrella of DevOps Toolkit series. I also wrote DevOps Paradox and test-driven Java development.
And we're here today to talk to you about progressive delivery. When have you heard the first time about progressive delivery, Victor?
I heard it the first time from you.
Well, I heard the first time from Lunch Darkly. They wrote this blog about the history of progressive delivery. So that was the first time. And then James Governor from Redmonk, Monk Chips in Twitter, he was pushing it, and I said, well, I love this term. It defines very clearly what we're trying to do. So let's steal it, right?
Exactly. We're not going to invent anything new, right?
Right. So what is progressive delivery? Is just a new term to coin a bunch of different things that have been around for a while. So it groups together all these deployment strategies that try to avoid all or nothing deployments, where you deploy something, and if it's broken, it breaks all your customers. So we are trying to avoid that, and that's all these techniques fall into the progressive delivery buzzword, I say. So when you deploy a new version, you are not replacing existing versions, but you just deploy things that are running in parallel with the previous versions that you have deployed. And then you can decide whether you want to send live traffic. This is important. This is all in production happening. So you can send live traffic to the old version or to the new version based on whatever parameters you decide. And then you evaluate whether this new version is behaving correctly. And if it's so, then you can send more traffic to the new version. But if for whatever reason the new version doesn't behave as you expected, then you can start rolling back to the old version. And this is very immediate or fast. And just a percentage of your users could get affected.
So the main advantage really of continuous progressive delivery or running in parallel, it is really about avoiding downtime. Because if you do not run 2 releases in parallel, it is physically impossible to be able to deploy a new release without downtime. So running in parallel is a prerequisite for any attempt to do no downtime or zero downtime deployments. And then on top of that, we have all the benefits that Carlos just mentioned, that we can decide how much traffic goes to one release, how much to another, and increase the reliability and confidence we have in rolling out something.
Yeah, and continuous delivery is pretty hard. And progressive delivery tries to make continuous delivery easier to adopt by reducing the risk associated with continuous delivery. A lot of people see continuous delivery like, oh, this is very dangerous. I commit something, now it goes into production to all my customers, users. So progressive delivery is trying to avoid that by saying, you push something to production automatically, but not everybody's going to get it at the same time, just a percentage of your users. So it's all about avoiding downtime and limiting the blast radius. So if something goes wrong, just some people notice what the issue, and also allows you to have a faster, like idea to production type of workflows where you are more confident that things are not gonna cause a big issue in production. So there's a number of techniques that you may have heard of. This is nothing new. So we have like things like rolling updates. So this is something that you could have done with virtual machines. You can do it very easily in Kubernetes with containers, with pods. And basically it's just, you have 10 pods running, and then you upgrade one to a new version. And instead of operating all the 10 at once, you operate one, check that that one is successful, or you have some maybe metrics. Then you operate 2, 3, 4, 5, and so on until you operate all of them. So you don't have a lot of control, but at least you're not affecting all the users at the same time.
So rolling updates is not that much about control. It's more about avoiding downtime by replacing one release one replica at a time. There is always a replica running, be it of the old or the new release or both. So it's not that much about having control. You don't really control who gets to see what, and you cannot even control much whether you roll back or roll forward. It's more about reducing downtime than anything else.
Yeah. And as I said, this is very easy to do in Kubernetes. Then we have...
It's a default deployment. It's a default deployment mechanism in Kubernetes. In other words, if you use Kubernetes deployment or stateful set, you are getting rolling updates no matter what you do, unless you explicitly change the deployment strategy to something else.
And then we have blue-green deployment. This is something that I think it came from Martin Fowler. I mean, he was the first one kind of going through the definition, where you have two different sets of clusters or machines. One set with the old version, one set with the new version. And then you have some router load balancer in front. And when you want to deploy to the new version, you just flip the switch on the load balancer and say, all the traffic goes to the new version. So...
sorry, it wasn't me. Fuck me. Basically, okay, so the main issue with blue-green deployments is that it somehow assumes that the best way to roll back or to roll forward is by having everything duplicated. It assumes in a way, and simply because it was created a long time ago, it assumes that rolling back, for example, would require creating of new virtual machines, would require a lot of many different steps. So in order to avoid the downtime, no matter whether we're going forward or backwards, everything needs to run in parallel. But now, assuming that we are using Kubernetes for most of our workloads, then the difficulty of going forward or going back is basically non-existent. So the whole idea about running everything twice in parallel forever and ever is kind of waste that could be probably avoided. So it is much better suited in environments where deployment takes time and scheduling takes time and what's or not.
If you have plenty of money, it's a valid solution.
Yeah, it's a typical solution where you have a company that has two data centers, and then one is used for, let's say, green, the other one for blue, or two sets of virtual machines completely separated. It's very close to the traditional ideas that people have about disaster recovery, but applied to deployments.
Yeah. And then we have Canary deployments, which is like probably the best way of doing things today, where you have sort of like same thing with blue-green deployment, where you have two versions running at the same time. It's just that you don't need to have a whole copy, and you are able to start sending users to the new version, and you can start sending like a few percentage at a time, and based on different metrics. So you could say typically what companies do is, okay, first only employees access the new version. So if there's anything wrong with the new version, employees detect it before it reaches to external users. And then you could start saying 10% or 5%, and then 10, and then 15, 20, 30, 40% of users are going to the new version, while the other ones are stuck with the old version. And then you keep rolling the percentage of users that are going to the new version, and the other percentage goes to the old version, and you can stop this rollout at any time and start and switch it and send everybody to the old version.
So the main difference, I would say, between rolling updates and Canary deployments is that with rolling updates, you're using very simple health checks normally to decide whether to go forward or to go back, without really control who sees what and how. While with Canaries, you would basically use heavily rely on metrics to decide whether something is successful, and if it is successful, whether to move it forward another 10%, 20%, or whatever the percentage is. So it is, you can say even that Canary deployments is a form of testing where you are, you deploy a new release, you allow certain percentage or certain region or certain users to see it, you test, and by testing I mean evaluate metrics, evaluate query metrics, evaluate the results, and then decide to go forward or backwards. So it is in a way similar to what we would do when deploying to integration environment, staging environment, production, except that this is all happening in production, and the use cases or test cases are based on input from real users rather than imaginary test cases.
Yeah, this is testing in production. What could go wrong, huh?
Exactly.
And the last way of doing things is, and that you can combine, this is the interesting part about feature flags, that you can combine them with any of the other ones. And feature flags and Canary deployments make a pretty good combination. So they are like, feature flags are like toggles, switch that you can turn on and off anytime at your application runtime. That's the interesting part. So you can deliver new features that are off by default to production, and then you can enable them or disable them if there's any issue with them, right? So you build a new, nice, I don't know, like UI, and then you can flip the switch and start showing that new UI to a specific subset of users. And if something is wrong, you just flip the switch again and go to the old version. So it's very nice because you don't even, we were talking about rolling deployments and rolling applications and so on. With feature flags, you don't even have to compile anything again or deploy anything again. It's all happening in production.
You still need to run multiple replicas of your application and do some form of, let's say, maybe rolling updates to prevent downtime, but you do not necessarily need to measure, to actually decide who sees which release, depending on where you're forwarding traffic, but rather by enabling and disabling features in that new release. So it's usually a combination of running multiple replicas in some form of rolling updates, Canary deployments, also not combined with the fine-grained ability to enable or disable specific features. While Canary deployments are allowing you to enable or disable visibility or specific release, this is rather on a feature level.
Yeah, and I think we heard this before, right? Monitoring is the new testing, in the sense that if you have good monitoring, you can know when users are experiencing issues in production. And not only that, but you could react to the issues automatically. You can rely on metrics to decide whether you want to continue a Canary rollout, whether you want to disable a feature flag because it's broken, and you can do very cool things. And it's pretty necessary to have good metrics and good monitoring, and have a good view of what your system is doing on production to do any sort of progressive delivery. And like a DevOps word, you used to say to make error is human, to propagate error to all server in an automatic way. That is what DevOps is. And this is the first time we mentioned DevOps in the whole talk, so that this must be a record.
I bet no other talk managed to get this far without mentioning DevOps.
Yeah, and something I experienced and I learned from that is like, if you haven't automatically destroyed something by mistake, that means that you are not automating enough. Have you went through this? Have you experienced it?
Oh yeah. Actually, if you want to be secure, the best way to do is to do nothing. And then the second best level is not to do anything automatically, and then you get to automation.
So let's go on to an example on how you practically do progressive delivery on Kubernetes, specifically Canary deployments. So let's talk about Istio. If you haven't heard about Istio, it's a service mesh. You probably heard about 5 different of them. Istio is one. And Istio allows us to do very interesting things with your services in Kubernetes. So Istio connects services, allows to secure those connections, doing like automatic encryption, and also control the flow, so deciding what traffic goes to what service, and providing us observability metrics on these services. And the interesting part is that you don't have to do anything to your application. You get all these things for free when you run a service mesh like Istio. Similar with other ones, but this example just uses Istio. And all these metrics that Istio collects, like you can get response times, you can get HTTP status codes, all of this, again, without touching your application, get stored in Prometheus, the most popular monitoring or metric store for Kubernetes. And another interesting project, the most interesting project in the sense of Canary deployments, is Flagger. It's an open source project that automates the promotion of Canary deployments using Istio and Prometheus metrics. So when you deploy a new deployment on Kubernetes, Flagger is there listening to events and sees the new deployment if you have enabled Flagger on it, copies that deployment over, so it keeps 2 versions of this deployment, the previous version and the new version. And it uses Istio control to start sending traffic, instead of sending all the traffic to the new version, gradually rolling out to the new version. And you can customize whether you are sending, 5%, 10%, 15%, and whatever number you want to set. This new traffic goes to the new version, and the metrics from Istio are ending in Prometheus. And Flagger looks at those metrics and says, this metric is okay or is not okay. So based on those metrics, it does continue the rollout, or otherwise does a rollback and it starts sending all the traffic to the previous version. So it does this by creating virtual services in Istio, primary and Canary services and deployments of your application, and continuously looking at Istio virtual service metrics in Prometheus. And you can even get messages in Slack when these rollouts are happening, because who doesn't need more Slack messages? You also get a Grafana dashboard where you can see side by side old version and new version. So again, all sorts of things like response errors, response times, and you can see both old version and the new version. And it's really cool. It's a really cool project. You should totally check it out.
Yeah, One additional note is that you were hearing about Flagger in combination with Istio, but if that's not your flavor, that's okay, because Flagger supports basically almost any service mesh available. On top of that, it supports even without service mesh. It can work with Nginx Ingress and a few others. So think of Istio in this context as example, not necessarily the requirement for Flagger.
Mm-hmm. And now let's go on to the demo.
Yeah, demo time. Let's take a look at Flagger definition first. It is kind Canary. That's not really anything special. What matters is that we are setting provider to Istio in this specific case. We are specifying that the target reference, the application, is running as a deployment, and it is called GoDemo 7. And on top of that, we are using some analysis, which we are not going to go into right now. What matters just is that Canary will be monitoring metrics in Kubernetes. Sorry. What matters is that Flagger will be monitoring metrics in Prometheus, and depending on the outcome of those metrics, decide to move forward or roll back. So we are going to apply Flagger. We are going to apply Flagger definition, and then we are going to take a look at one more resource, which I should have applied before, but this is a definition of Istio Gateway that defines the entry point to our application through which we will be able to access it. So all in all, what we are doing here is that we have an application, it's a Kubernetes deployment, we have Flagger, and we have Istio Gateway. Everything else required for that application, like destination rules and virtual services and what's not, all that will be created by Flagger out of the box the moment we deploy the first release. Actually, we already deployed the first release, so we're going to see how the second release comes along, because that's the more interesting part. So let's take a look at the deployments. Now, this is important because here we can see that we have a database. That one is not important, but we have GoDemo 7 and GoDemo 7 primary. Now, GoDemo 7 is the deployment that we deployed. The other one, the primary, is created by Flagger, and that is actually the release that Flagger will consider the production release, while whatever we deploy ourselves will be copied by Flagger and converted into next production release when the time comes, even if all the conditions are fulfilled. Another thing important here that we can see that we have HPA, horizontal pod autoscaler, which will scale our application and to anything between 2 and I don't remember anymore how many replicas. So let's send 10 requests to the application and confirm to begin with whether it works, right? So we are creating a loop of 10 iterations, and in each of those iterations, we are going to send a request to the application, which is configured to answer to requests based on the domain godemo7.acme.com, which we are faking right now because this is running in Minikube. And then sleep of quarter of a second between 2. And we can see that we are running now the first release 001. We did not yet do Canary releases, anything like that. I just confirmed that we are running the first release in production or simulation of a production. And here we have services that were already created by Flagger, right? All those here, except the database, were created by Flagger, managed by Flagger. We don't need to do much over there. So just as a confirmation that Flagger creates everything we need, here we can see destination rules also created by Flagger. Not much for us to do. It is doing basically everything for us, or almost everything. The only thing that we really need to do is deploy a new release, is a new deployment or a new stateful set of our application. Similarly, here are virtual services, which there is only one for now. There will be more later on when the new release kicks in. And the most important one is Canary resource, which there is only one right now, and it is initialized. The first release is always only initialized. We will see what happens when we will see what happens when follow-up releases are deployed and how Canary does all that.
I mean, that's the beauty of Flagger, right? You focus on your application, and then it will, from the CRD, the Canary CRD, it will create all these things for you magically.
Exactly. It is similar in that aspect, like let's say Knative, which also creates many other resources that you would normally do, simplifies deployment quite a lot, apart from doing what it's supposed to do, and that is Canary deployments. So what we're going to do next is deploy release 002, and I will show you here the YAML. This is basically exactly the same YAML as of the initial release. The only real difference between this deployment and deployment that is currently running in production is in the tag, right? The previous one is the current one is actually running 001, and now we are about to deploy release 002. It's more or less the same application. It just outputs the release version to std out.
And you don't have to change any of your pipelines or workflows. You just have to deploy a new deployment in Kubernetes.
Exactly. And see here, if you look at the differences between the two, we can see that the only changes between the releases now is in the tag. So what we're going to do is output the IP of, in this case, of the gateway. And then we are going to create a second terminal to run in parallel. On the right side, you will see very soon a loop. Requests will be sent to the application in a loop so that you can see how it progresses, right? The current version of the application, the one running in production, is supposed to output something version 001. And as Canary starts rolling out the new release, you will see increase of the percentage of the outputs that state that the release that is running is 002. Okay, so as you can see, all the outputs are from the existing release, it says version 001. So what we're going to do is apply the new deployment, the deployment of the new release. So the only thing that we're changing in the system ourselves is updated version of Kubernetes deployment. We're not changing anything else. We're not doing any other action except deploying, overwriting the existing deployment with a different image, with a different tag. And we can see that we have two deployments. The new one, GoDemo 7, is currently running 0 replicas. That will soon increase when horizontal pod autoscaler kicks in. And if you look at the virtual services, we can see that we still have only one.
And this makes a lot more sense when you have multiple replicas and even the HPA, the horizontal pod autoscaler running. So you have more room.
And if you look at the service right now, virtual service from Istio in this case, we can see that there are two destinations, there's the two routes, one sending 100% to the existing production release or primary, and 0% of the traffic is being sent to the Canary release, to the new release. And the reason for those 0% is because Canary Flagger did not kick in yet. Soon you will see the change of that percentage once new deployment is operational and Flagger discovers that there is a change of that deployment.
Yeah, Flagger basically is stopping your new deployment from getting accessed and then slowly turning it on for the users.
And now we can see that the percentage is changed. 80% is going to the production release, while 20% is going to the new release. And if you pay attention to the right-hand side of the terminal, you will see that occasional outputs are now saying version 02. approximately 20% of out of every 5 requests are responding currently with version 0.2.
And this is random, but you could also set by like HTTP headers and other sort of rules.
Exactly. Currently, rules, if I remember correctly, the definition are based on the error rate, I think, or something like that. Simple one. But yes, definitely in real production usage, you should change that to be real metrics, real queries, real error detection, user satisfaction, or whatever else you deem important to decide whether to move forward or not. So let's describe Canaries one more time. And now we can see that it increased to, Canary weight increased to 40%. So it saw that there are no problems, no errors, no issues with the new release, and it decided to move forward another 20%. And if you pay attention on the right-hand side of the terminal, you will see that approximately 40% of the responses are version 0.2, while 60% are version 0.1. And then the story continues and continues. We will continue outputting Canaries a few more times, especially if I stop making mistakes and forget to put the namespace. There we go. And we can see that Canaries are now progressing, and 60% of the traffic is currently being redirected to the new release. By default, and this can be changed, once it reaches 60%, it is configured to finalize the release. It assumes that if 60% of your users of the traffic, or whatever the criteria is, has been valid, there is no point probably to continue progressing to 80%. It will jump straight to 100% and finalize the deployment of the new release. So soon, within a few moments, all the traffic, everything coming into this application will be redirected to the new release, if we are patient enough.
Yeah, obviously you would do this over a longer period of time to make sure that you get users hitting the application and exercising all the possible paths and features.
Yes. But then the demo would be boring. That's about it. Now it is promoting, meaning that it is removing the Canary release and it is changing the primary release to be the new release. And basically this is it. Even though the process did not finish yet, basically it is finishing our application. All the traffic of our application is now going to the new release. And you can see from the output on the right-hand side of the screen that all the responses are now 0.2. That's it. We're successful. We've proven that it works in production. Just apply it and that's it.
And if for whatever reason the metrics have failed, Flagger would just change the service, the EST virtual service pointing to the previous version and eventually delete the new version as a failed rollout.
Actually, it's a bit more complicated than that. It would, if it fails, then it would try again and again, depending on how you configure, because maybe there is occasional glitch or something like that. But if it continues failing over a certain period of time, or a certain number of iterations, then it would say, okay, I cannot take this anymore, go back.
Yeah, this is all configured on the CRD, on the Canary object, the metrics and the times that you want to retry.
That's it. The rest of the presentation is showing Grafana, but I think that we have more than enough now.
Okay.
You want to show Grafana?
Let's record it.
Okay, so let's take a look at metrics in Grafana, which we already mentioned, or to be more precise, metrics are in Prometheus, not only metrics that the Canaries are using, but quite a few other metrics. So let's install Grafana and take a look at very quickly at the dashboard over there. So we are going to start port forwarding because I don't have a domain for this demo to localhost and open Grafana in a browser and see what happens. Okay, so this is Grafana. Okay, so let's open Grafana. We're going to output first a JSON that contains the definition of a dashboard in Grafana. I'm going to copy it to memory, to pb copy, and then we're going to open Grafana. We're going to jump straight into import screen of Grafana to import the dashboard.
Typo.
Okay, so this is the import screen. I'm pasting JSON that contains already dashboard definition that we're going to use. And here you can see pretty colors. There is green, there is blue, there are certain percentages, there are certain results. We're not going to go through that simply because we don't have enough time. And also the sample that of the data that we are having is relatively small to have substantial dive into this dashboard. What matters is that there is dashboard. If you're bored with Netflix, you want to change what you're watching, there is a dashboard. You can watch it until there is no tomorrow.
Okay, well, thank you for listening to us today. And we hope you learned that you can do progressive delivery, Canary deployments on Kubernetes. It's very easy. You don't have to be Netflix or Facebook or a big corporation to do this. You can just use open source projects to do it. Right, Victor?
Absolutely. Basically, it's almost too easy. The main difficulty is whether you really understand under which conditions a release is successful. Because you will need to tell, in this case, Flagger, what those conditions are. And that is probably the most complicated part, because it's very easy to say, okay, just move forward 20% every 5 minutes. But figuring out what are the potential errors that the machine system needs to discover in order to decide whether to move forward or move back is the complicated part. Outside of that, so if you know your system well, if you know under which conditions something is a success or a failure, then it's fairly easy.
Yeah, and it's not only metrics about, HTTP traffic. You could also have your own metrics, like business level metrics, like how many items are people putting on their shopping carts, or how many credit card transactions we have. So you could also, and it will be very nice to have those type of business level metrics that mean more to you.
Exactly.
Well, with all that,
Okay, so thank you.
Thank you for being here virtually.
Thank you, guys.
Hey.
Hey, how are you? Feeling tired? I'm joking, of course.
Tired of speaking for half an hour?
So did you have the chance to follow the stream, to see the video?
Yep.
Yeah.
And?
Answering a few questions.
We learn everything new, something new every time we watch it.
Okay,
Yeah.
so do you have any questions for the speakers?
Do we have questions for the speakers?
Yeah,
Do you have questions for the speaker?
of course I have, but first I must ask if you have questions for the speakers. Victor, do you have questions for Carlos?
Okay.
Vice versa?
So Carlos, what is Kubernetes? That was the confusing part.
No idea, no idea. Start with K, lot of word, big word.
So I have a question for you guys. So I really enjoyed the definition of true DevOps, from DevOps Borat. Have you been in that situation at least once in your life? I know, of course not. You're not damaging things, at least not in an automated way. But
no, we do damage things in automated ways. That's the beauty of it. Yeah. Yeah, I mean that happens, and I think that's a good way. It's actually true, right? I don't know. In a previous company I work, we use Puppet to deploy to a lot of VMs, and then suddenly you make a change, and it seems fine, and then you deploy it, and it breaks something, and not only breaks something, it breaks Puppet itself. So you cannot deploy automatically more. So you have to go and manually fix it. So that's one of the things that automated failure, right?
Okay.
So, but that's good. I mean, you have to automate things.
Yeah.
I mean, it's still better to break some 100 servers automatically than to spend 5 days breaking them manually. So
Okay.
it's not really a bad thing.
Yeah, in the economy of time, that's absolutely.
The faster you break them, the faster you can fix them too.
Okay,
Exactly.
So fail early, right? So you can learn from it. Okay.
Fail fast, fix it, and if you can't, change the company.
Someone else stays with the responsibility, okay?
Exactly.
Okay. But just to summarize, what is fundamentally the difference between the progressive delivery and continuous delivery? I'm asking this because we had yesterday Dave Farley in the conference, and we had a little conversation. So initially he considered that continuous delivery is just a set of practices. So 10 years ago when he released the book. But with time and while putting it in practice more and more and more in many companies in the industry, is now convinced that this is a true methodology, a true engineering thing.
I don't. They're very different things. At least from my perspective, continuous delivery is about automating full life cycle of your application, right? From committing something to Git all the way until it is running in production, potentially even monitoring, observing, and what's not, right? Now, progressive delivery is one of the ways or a group of ways to deploy, right? And deployment is only a fraction of the whole process, right? So progressive delivery is a way to deploy something, and it can be further split into Canary deployments, rolling updates, blue-green deployments, what's not. But they're all a way how to deploy application. And continuous delivery, or continuous deployment is much bigger in the scope of what it does. It's a full life cycle of an application. Mm-hmm. I don't know if Carlos agrees.
I don't agree, of course.
Okay, bug off. Shut up then.
I think it's more like a specialization or a continuation. I don't know. You could consider that progressive delivery falls inside continuous delivery or not, or is just a step after or something. But it's not necessarily just deployment, but because there's things that you have to consider before that, right? If you use release toggles, you have to consider that before. And so it's not just deployment in the same way as continuous delivery. Yes, it's not just deploying, quickly deploying things. But it's not like a term that anybody has decided exactly what it means. So it's open to interpretation. It's the main factor that defines progressive delivery is that you do not want to deploy something to multiple users at the same time. I mean, to all the users at the same time. And you want to have quick ways of going backwards. And this is a simple thing to say, but it has a lot of implications. Like you can do a lot more experiments faster, recover faster, be less afraid of making changes, and that inherently improves the quality and improves the speed of delivery.
Okay, that clarifies it. Thank you very much. The other question I was having is, in terms of the tool belt that me as an engineer, I must have, skills, languages, whatever that tool belt would be. What do I need to learn?
In general or progressive delivery?
Let's start with progressive delivery to make it simpler. And then
yeah,
for the DevOps profession, or if there is such thing.
For progressive delivery, there is tools now. I mean, there has been tools before, like Spinnaker has been around doing Canary deployments. There's now Flagger for Kubernetes. There's the service meshes and stuff like that that will help you achieve this. And then there's all this monitoring metrics, observability stuff that it's getting more and more. It's easier and easier to use now. For everything else, what do you think, Victor?
I mean, I would say that, Flagger or other similar tools are almost coming at the end of the process, right? You do need to figure out how to store metrics. You need to figure out which metrics can be used to test whether something is successful or not. Service mesh potentially, Kubernetes definitely, and so on and so forth. So it's almost like icing on top of the cake, right? Flagger or Argo rollouts or any of those tools. I think it's potentially very dangerous if people just jump directly into Flagger or Argo rollout or whichever tool you choose, because if you don't really understand everything that it orchestrates, then it can be very, very dangerous. Mm-hmm. So basically learn everything.
Okay, I'll start right now. Immediately.
You're late already.
I'm late already. Yeah. That's
and
true.
For other tools for DevOps, that's a tricky question, right? I mean, Kubernetes, I think it's gonna stay, right? It's gonna be the new Linux, the new operating system, and cloud infrastructure is useful, but kind of Kubernetes abstracts you from a lot of it. But more likely than not, it's gonna you're gonna need to know about infrastructure, and in general, anything that relates to serverless and Kubernetes and I don't know, services more than anything else is what I think is coming up as the future or a way to do same things faster.
Okay.
I guess it depends also really what you want to accomplish. If you want to be prepared for what's coming, then that's one story. If you want to kind of like support existing applications in existing infrastructure and stuff like that, that's a different story. But if you want to be prepared for what's coming, then just go to CNCF. That's a good starting point. It will take you 3 years, and then see from there.
I mean, the goal is always, what do I have to learn so I can switch companies and get a better job, right?
Exactly.
Do you consider DevOps as a profession? Because the industry discusses about DevOps as being a culture of collaboration between people, tools, and everything in order to deliver value fast.
To me, that's the first part of the sentence, and the second is very contradictory. It is a culture, right? It's about people working together in a way. It's about acknowledging that people like Agile forgot that there are there are some other people in the company, like sysadmins, operators, what's not, right? So it's really about collaboration. It's about removing silos. Now, if you accept that as a very high level definition, then being a profession is quite contradictory, right? Because if there is a profession, that's yet another silo. That's yet another department that is doing something, right? So I'm very, very opposed to hearing things like DevOps engineer. I don't think that there is such a thing.
Yeah, I think it's damaging. Well, it's not what the initial thought was. So I think even Patrick was stopped fighting it anymore. So DevOps team is definitely something wrong. If you hear about a DevOps team, then you know that that's something wrong about that. DevOps engineer has came to mean, even though initially it would be wrong, it just came to mean, I don't know, like a sysadmin that knows how to program or something like that. And I think the good thing about DevOps that our companies are mostly getting right is that they're building teams based on functionality more than expertise, right? No more dev, QA, ops teams, but more like vertical teams that have people from different parts of the expertise and joining into building a feature. So that I think it's getting right. The naming I think is bad in general. People just call DevOps anything, but there's good changes that DevOps brought to the companies.
It's confusing because people try to choose their careers, and suddenly we've got this DevOps career. So what do I need to do? What do I need to learn? What kind of experience do I need to have, background and everything, so that I can do the job? So basically, what you're saying is that you're an engineer with the right skill for the job, right?
Well, I mean, what people call DevOps engineers today is somebody that knows a bit of operations, a bit of, I guess, containers and stuff like that, and infrastructure, but more in the sense of cloud infrastructure. So a bit higher level. So it's not a low-level operator, but it's somebody that has like a low level, but not too low, up to the application stack, right? I think that's what most people call a DevOps engineer. So something between sysadmin and developer, right? So touching different things, and especially touching things that are infrastructure in cloud. So not bare metal.
Okay, got it. In addition to that, we now have QA ops. We've got art ops from architecture. We've got data ops.
Mm-hmm.
What else? Fin ops, win ops, probably more ops.
I'm very negative. I'm very negative towards all those. I think that it's a marketing stunt, right? Companies are inventing names that really have no real meaning and are very often damaging to the whole idea, right? It just, I cannot even contemplate what would be QA ops. I cannot even imagine what that could be.
We even have the DevOps toolkit.
Yeah. I mean, now I understand kind of like everybody wants to jump on every new wave and get, so I completely understand that somebody says I'm a DevOps engineer because that's going to give me better salary or a job somewhere. I understand that. I understand that companies are naming something like continuous this, continuous that, and then something ops, something else ops. I understand why they're doing it. Still, it's silly. It provides no real value. So I'm very negative about it.
Okay. What's Dev paradox?
DevOps paradox?
Yeah.
Yeah, that's basically, I did a lot of interviews with people and every single one starts with unscripted, so no prepared questions, none of those things. Only one question prepared at the very beginning: what is DevOps? And every single person gave me a completely different answer, which I think reflects that we don't really, from practical perspective, DevOps is a completely random set of things, right? And practices and what's not, and everybody's trying to bend it to be whatever they would like it to be, right? And it's called DevOps paradox mostly because basically, if you read those interviews, you will think that the world went crazy. And then most of the people interviewed there are considered, I mean, not considered, they are really prominent figures in the industry.
Yeah. In the end, what's in a name, right? As Shakespeare said a while ago, the rose will be as beautiful as. Okay. What's your next plans? What's your next targets? What are you? How are you moving the world forward?
Right now, not moving much.
With the power of digital and your DevOps engineering and progressive delivery.
I mean,
yeah, but it's not as much fun as being there in Romania, having some local drinks and food. But what can we do?
Definitely looking forward to your next visit once this lockdown is finishes and the entire situation. So guys, it's been a real pleasure. Anything else you'd like to share with us?
Figure it out. That's the best answer anybody can get. Things are changing very frequently, and we are all trying to figure out what to do next. I think that should be a job description. I'm figuring it out.
I guess the last question is related to the something that which reminds me of a joke. So compiles, ship it. And you mentioned during the presentation that the principle that the monitoring is the new testing. And I understood the meaning of the words, but how can we make sure that it will not be interpreted as compiles, ship it?
It's a matter of, there's all sorts of testing that you can do, but no matter how much you test, like unit testing or integration testing, no matter what you do, I mean, customers, users will find a way to break your application. The real world is always going to be doing something that you don't expect. So you got to be ready for that, right? So you can do 100% test coverage and whatnot. That's not going to help you when, I don't know, some machine goes down in the middle of a request or something like that. So that's about the resiliency and making sure that your things are working in production. It's very important.
And it's kind of an acknowledgement that until you reach production, you don't really, truly know how it will behave, simply because you can never replicate production. You will never have hundreds of thousands of users in a lab environment, right? So I think it is important that we are shifting focus, not kind of changing, but adding focus to testing in production. And testing in production is very different than what traditionally testers are used to, right? It's much more about observing what is happening by random people doing random stuff than having predefined steps, Now I run this, now I do that.
Yeah, I get it. So a tough life, right? To be a so-called DevOps. So you cannot. You just have to live with the emotions. Yeah, that something is going to happen, but it's normal. We're going to fix it, and we're going to be proactive maybe next time. Or
look at it this way: if that wouldn't be true, then half of us wouldn't have jobs.
There is I mean, the first step is to figure out when something is wrong. I think there's a lot of people running stuff in production that, and probably even me, there's cases where your things that are running in production, you don't know when something is wrong. So starting with that, how long it takes you to figure out, right, that something is wrong, and something is wrong in a user point of view, right? So users are trying to, imagine Amazon, users are trying to add things to the shopping cart and they can't, right? And obviously you want to detect that as in like less than a minute, because you're losing millions every time for every minute that's not working. So there's a lot of services out there that you use, right? You go to some web page, you try to use it, and you cannot pay because of some issue, or you cannot buy something, and you are like, how that can happen, right? And just having that first step of knowing observability, monitoring, something like that, right? Knowing when things go wrong, and then start building from there. Like if I know when something is wrong, then I can start thinking how to proactively fix it or proactively avoid it, or not fix it, but maybe react and do something else, right?
And with this, we're going to close the second day of the DevOps conference, which is part of the entire week called the Code Camp, the online gathering. I'm very much looking forward to meet you in person again here in Iași, or in Timișoara, or in Bucharest, or in Cluj, or maybe in Barcelona, maybe.
Likewise.
So now,
thank you very much. I really appreciate.
Stop talking, go and find the vaccine, fix the problem.
Okay.
If you really want us to come.
Okay, so I have two things to work on, right? My DevOps career, so I start now, and also the vaccine.
Yeah, if you find the vaccine, you can forget about the DevOps career. You're
No need, no need.
Both are challenging for me. So, okay, guys, thank you very much.